Okay, hello everyone. Welcome to session 2 in day 2 of PyCon Indonesia 2020. My name is Sigit Dewanto and I will be the moderator for this session. The speaker for this session is my colleague from Scrapinghub, Kevin Lloyd Bernal. I'm not sure how to pronounce your middle name.
Yeah, just Lloyd.
Lloyd Bernal, okay. Kevin is currently technical team lead and senior software engineer at Scrapinghub. He is also one of the maintainers of the Scrapy framework. He is also currently studying master in computer science at Georgia Tech University. On this talk, Kevin will deliver a talk about web crawling and data extraction in Python from basic to advanced use case. I think this will be an interesting talk. So for the participant, if you want to ask questions, you can use Hopin chat. And without further ado, the stage is yours, Kevin. Let's give a big virtual applause for Kevin.
Right. Hey guys, thanks Sigit. Right, so for this talk, I would be going over the various different web crawling and data extraction tools available in Python, so you could actually use the most suitable ones for your next project. So this would be a survey on a lot of different Python open source tools that I could fit in the allotted time. But before that, I want to introduce myself. So hi, I'm Kevin. So I'm from the Philippines, and I work remotely as a tech team lead at Scrapinghub, and also currently taking my master's degree in computer science at Georgia Tech. Right, so this is the problem that I'm trying to address, and that's okay because a lot of different software engineers are trying to ramp up their project or next project, which is involving web crawling or data extraction or web scraping, and they just don't know which tools to use because there's just so many Python tools, open source Python tools out there. So my talk is all about web crawling and data extraction. And I want to highlight out that I would be giving an overview for a lot of different tools out there. So we're going to be covering far and wide instead of just picking one tool and just going deep with it. So apologies in advance if I actually am a bit fast for this talk because I have lots of slides to cover. And I want to cover a lot of tools in the allotted time for this talk. Right, so the main takeaways you should get after the talk is you should at least have an overview of the tools for your next web crawling project. And then for the scope for this talk, this only focuses on the tools and not the actual techniques involved in web data extraction or crawling. And just as a disclaimer, like Sigit has mentioned, I work in Scrapinghub, which is the main maintainers for Scrapy. So most of the tools and concepts that I would be discussing for this talk would be revolving around my day-to-day work, and also revolving around Scrapy. So there's just a bit of a bias here, but I would also try to include a lot of open source tools out there in Python that does not involve Scrapy. Right, so just to give you out a personal example of like how I actually started in web scraping or web crawling. So this is the first spider I've actually written down, which was 4 years ago. So I traveled quite a lot pre-COVID. Just so to find the best deals out there, I actually wrote a spider just to alert me if seat sales are available. So for the in Southeast Asia, there's a lot of different airlines like Cebu Pacific here in the Philippines. In Malaysia, there's Air Asia. So a spider would actually save me a lot of time because I actually automate those actions just to see if there's some good deals out there. And the second spider I actually wrote was for Twitter because back then, around 4 years ago, there were some API limitations. Though I'm not sure if Twitter actually fixed it now or there were some changes in the API. But I was into stock trading before, and I wanted to analyze, the market sentiment on a given stock. And traders in the stock market had Twitter, and they actually tweet, the stocks they're actually trading for that point in time. So using a spider that would get the tweets for me and feed it through a market sentiment pipeline, I was able to determine which are the stocks in a given day are actually hyped up by traders. Yeah, so I think that's the two main spiders I wrote before joining Scrapinghub. And before going over my talk here, I just want to highlight the table of contents. So we're going to be mostly discussing 3 use cases, basic, intermediate, and advanced. But first off, I want to define some terms I would be using quite a lot in the next few slides. So this is just a really simple diagram of a spider, or rather a script, in Python, which has 2 main properties, or rather actions to it. So first one is crawling, and the second one is extraction. Crawling is just a concept of visiting a page into another page and so on, and extraction is simply parsing the data set from a given page. For parsing, or rather extraction, there are some extraction rules that we need to define. So extraction rules are basically how data is to be extracted from a given HTML document or XML document. So there's like 2 main extraction rules that I would be mostly going over for this talk. So the first one is CSS rules. So if you're a web developer, this might be natural to you because you use this quite a lot often in order to stylize a lot of different page elements in your web page. But then there's also a second one here named Xpath Rules, but that has a bit more features than CSS rules for traversing HTML or XML documents, but it could be a bit more complex. And it's also important to note that Xpath rules are also able to parse XML documents, not just HTML documents like CSS does. And to highlight, just a brief highlight here about the syntactical differences between CSS and Xpath. Suppose we have this HTML document here, and we actually need to extract this value highlighted in red. So for CSS rules, it would just take you, this rules, which are you're pretty much familiar with if you're a web developer. For Xpath rules, it's a bit different, and it looks like this one. So Xpath rules tend to be a bit more longer, but then it also has a lot more features than CSS rules. But I won't be going over the specific syntax of CSS and Xpath. I just want to highlight the main differences here. So when you actually start your web crawling project, you actually know the choices you have when writing the parsers. Right, so I think that's mostly it for the definition of terms. We're going to use those terms quite a lot in the next few slides. So I think we're ready to go a deep dive for the different use cases here. So the first one is just a basic example. So suppose we have a hypothetical scenario wherein we actually just want to do a one-time download of a data set from a given single web page. And for this example, I've taken this table from Wikipedia, and suppose we actually just want to transform this unstructured data set inside the web page into like a Python dictionary. So I see this specific use cases quite a lot, in this past few months because just of the pandemic, especially for data scientists that are looking for supplemental data on top of their current data set, just so they could perform a lot more analysis, right? So for this simple use case, we could use request library, which I know a lot of Python developers use a lot, and beautiful soup for the actual data extraction. And it would actually look like this one. So there's mainly 4 parts here. The first one is simply importing the necessary libraries. The second one is the crawling part, or rather requesting the web page from the given website, right? So we're using request.get for that one. The third one is simply converting the HTML document into a beautiful soup instance, so that in the 4th part here, we could actually use beautiful soup force API to extract a data set. As you can see here, these are the results in the given table. So these are the keys, and these are lists, which are the values of the dictionary, as you can see here. There's also another alternative that I want to introduce, which is Parcel, and it would also, look quite the same. So if you put them side by side, Beautiful Soup 4 and Parcel, it would, look pretty much the same, except for the actual API that Beautiful Soup 4 and Parcel are built on. So only this cell right here and this cell right here are the only difference between the sample code. And the reason being I want to introduce Parcel is that Parcel is part of the Scrapy project, which I would be talking a lot more about Scrapy later on. And Parcel is what actually Scrapy uses underneath. And it handles both CSS and Xpath expression rules because it uses LXML and CSS select underneath. And I believe the organizers will be sharing the slides for this talk, after the event is finished. So I've added a lot of links here. So you could play with Parcel in this sandbox, when the slides are set. So if you could see here in the really basic example, we have a Parcel selector here, and it has the CSS and XPath APIs to actually perform the extraction rules on a given HTML document. Right, so just to summarize what we've covered so far in the basic use case, so we only covered request library for the crawling part, and for the extraction part, we've covered both Beautiful Soup 4 and Parcel. But I also want to highlight that, there also exists a package out there named Requests HTML, which is also made by the same author with Request, which was Kenneth Wright's, but now it has been transferred to Python Software Foundation. So it's important to highlight this one because it has, quite similar API with request library. So if you'd actually use them in combo, you would feel much at home just because of the similar API there. And for the basic pros and cons here, so this approach is just quick and easy, to implement one-off projects. But then for the con, crawling gets a bit hard, or rather challenging, if it actually involves maybe hundreds or thousands or millions or billions of pages. So this is where the intermediate use cases come into place. So for the intermediate use cases, I would be covering mostly Scrapy, but I would be covering non-Scrapy packages later on. So Scrapy is a high-level framework for web crawling and data extraction. And it's very extensible with lots of different third-party plugins, middlewares, extensions, and so on, which I would be covering in the next few slides. And it's also battle-tested for 10 years now and counting. So most of the tools I would be going over for this talk would be revolving around this one. But then notice the emphasis on framework, which means you're going to be conforming to it compared to a library, say Parcel or Requests, right? Because frameworks tend to have their fixed approaches and APIs that developers need to conform to. So just keep that in mind. So just to demonstrate what Scrapy does, let's take a look at this really basic example here. So this page is taken from books.toscrape.com, which is just a practice site for developers wanting to try out Scrapy or maybe other web crawling or data extraction frameworks out there. And the objectives for this example is to simply extract all the books we could find. So in order to find all the books here, we need to traverse the list of book categories here on the sidebar. And for each book category, we also need to paginate through all of them, right? So each category here has around 1 to 20 results, and each category could have around at most 1,000 results. And writing a Scrapy spider would actually look like this one. It only takes 22 lines of code. And there's like 3 major parts here that I want to highlight. The first part is the actual data extraction. As you can see here, we're pretty much only extracting 2 fields, which are title and price. And then the next 2 parts here is actually paginating through the web pages in the current category, and the other one is traversing the other book categories from the sidebar. So there's three main parts happening here. The first one is extraction, extracting all the books here, and then the next two parts are crawling, both traversing the category pages and paginating through all the pages per category. So this is just, it's really quick and easy to create a Scrapy spider from scratch like this one. And Scrapy also gives you a lot of useful debugging mechanisms here. So if you're running the Scrapy spider, which we actually named books, going to my previous slide here, you can see the name of the spider here, which is named books. The command would just look like this one, and it would present you with some logs here, which I've pretty much screenshot. So the red arrows here are representing the items that were scraped from a particular web page. You can see here, you could also see the response status codes for each type of web page. Like it found a 404 page in /robots.txt because it doesn't exist. And before the spider, just finishes its run, it actually dumps some useful stats for you, like this one. So you can see here, it took the spider around 131 requests to get all the books, and it received 131 responses. And there's around 6,450 duplicates that it has, ignored because of the same title and price. And it has scraped around 2,000 items in the given website, and other stats like memory usage and scheduler memory, the queue and in queue operations here. So Scrapy by default takes care a lot of stuff for you, so you don't even have to write the logging mechanism, write the stats for your given spider, because it's built into the framework. And just to show you what the actual output looks like, it looks like this one. And it's able to detect the actual data format for your output based on the suffix here. In this case, it's .jl, which represents for JSON line. Right, so there's just a lot of built-in features available in Scrapy, and I won't have time to cover them in detail, but it's pretty much well documented anyways. So feel free to peruse the Read the Docs website for Scrapy project to learn more about it. Instead, I would be covering some very useful third-party plugins, so you could actually know which potential packages out there in the Scrapy ecosystem you could use, if you're actually wanting to try out Scrapy. So we're still in the intermediate use case here, but we're mostly going to be tackling Scrapy-related packages. So the first package I want to introduce is SpiderKeeper, which is just a dashboard, right, in Scrapy. So let's face it, if you have written multiple spiders, maybe hundreds of them, it's really hard to manage them and schedule them in the command line interface. So SpiderKeeper here is a dashboard, so you could actually manage and visualize their activities like periodic runs, finish runs, going through the items, logs, and stats, debug errors, and visualize the running performance. And would actually look like this one. So you can see the next jobs in the queue, the actual jobs running inside the platform, as well as the completed spider jobs here. It's also able to give you the stats of like how often or how many spiders were running in a given time frame, like this one. And it's also able to give you the ability to schedule periodic jobs like this one. So that's mostly it for the dashboard. The next one is automatic tests, right? So this is kind of the same way web developers are testing APIs automatically by actually saving the request body and then the response body into the code base, so they could actually run their code or API requests over and over again, which serves as both unit and regression tests. For Scrapy, Scrapy Auto Unit takes care of that one. So as you can see here in this red box, this is what Scrapy Auto Unit creates in your Scrapy project. And it creates a lot of fixtures, which contains the requests and response body that your spider has previously seen. And on top of being as a main primary source of your unit and regression tests, you could also go back in time to investigate a past issue. Say you've written a really bad parser and you just want to investigate what has happened there against an actual web page. You could do that one using Scrapy Auto Unit. The next one is Scrapy RT, which comes in handy if you just want to conveniently grab datasets into your existing system. So if you want to treat spiders as an API, you could use Scrapy RT here, and just avoid CLI altogether. And you could use this one on a dedicated server or machine, and it could function, say, something like a microservice, just a dedicated microservice for spiders. And instead of running them in the command line, you would just use requests like this one, and it would actually give you the logs here, the stats that I've shown you before, as well as the items scraped and items dropped. So this is really handy if you want to treat your spider as APIs. For the monitoring, Spidermon is also available, which allows you to receive different alerts via email, Slack, Telegram, S3, or Sentry. And you could customize it to whatever checks or validations you pretty much need. And this is just an example of what the email alert looks like, right? So you can see that the spider name here, name books, how many items it has scraped, request count, what are the errors here, some stats, and some data integrity checks and so on in a given email. So you could pretty much customize your spider alerts in any way you want. And then the next one is handling JavaScript pages, right? Because by default, Scrapy just is able to render JavaScript contents. So if you try to crawl a JavaScript websites like this one, quotes.toscrape.com/js, Scrapy would, see it as like this one, like there's no page elements to scrape from, mostly because the data has not yet been rendered into page elements inside the HTML DOM. So in order to do this one, you could use Splash plus Scrapy Splash to actually render the websites or JavaScript websites like this one. Alternatively, you could also use Selenium out there, or Puppeteer, or something like Headless Chrome, which is quite popular these days. Right, so there's just so much Scrapy related packages to share. The ones I've shown you are the most common ones newcomers need. So this is where we often see newcomers, wanted to suit their particular use case, and they have trouble finding the best Scrapy package, or rather open source package in Python for their specific use cases. So if you need more Scrapy related packages, feel free to peruse some of these links out here, because these contain a lot of links and packages for anything related to Scrapy. Right, so we're still in the intermediate use case here, but then we're going to be going over the miscellaneous helper packages that are unrelated to Scrapy. So the first one is number parser. And a lot of different websites spell out the numbers in text. Fortunately, number parser is there and is available for use, and it's really handy when cleaning out data sets. I think data scientists and a lot of analysts out there would really love this one, because they could just clean through the data sets from websites really easily. So you can see here, it's actually able to parse the number 2 and 37 in words into actual numbers. And it's also actually able to parse the number and the ordinal, right, like this one, also in words. Also, some languages are supported out there, not just in English. So languages like Espanol and Hindi are also supported. And similar to number parser, there's also price parser, but as the name suggests, it's just for prices. So if you have a price string out there and you want to parse it, you would just declare it like this one, and you're able to extract the amount, currency, amount text, and amount float, and so on. So this allows you to clean out the data sets from HTML web pages, and just clean it out there, like this one. And the next one is also related to the theme here, which is date parser, but for dates. So date parser could parse any dates you'd throw at it, like this one in different formats, like this one and this one, and it's also able to handle relative dates, like in 2 months. Suppose today's August 1st, it's able to determine that in 2 months it would actually be 2020 October 1st, and it's also able to handle timestamps here. Another alternative for dates would be Maya, which was also written by Kenneth Wrights, creator of Request Library. So some important features here to highlight the differences, or additional features, would be it's able to handle slang dates like this one, slang time, and some different standards for dates and time if your project needs it, like ISO 88601 and RFC 2822. There's also extract, right? Because a lot of different websites now have metadata, and they conform to different standards. So for PyCon ID for this conference, if I were to share this URL into a Slack bot, it's actually able to present me with a preview of like a description and an image inside Slack itself. And Slackbot, or rather Slack, is able to do this one via parsing the different standards inside the web. For PyCon ID, it's actually using the Open Graph standard, which is created by Facebook. There's Extract also supports microdata, JSON LD, and so on. So if you'd actually want to parse metadata like this one in websites, you could use Extract for it. Right, so I think that's it for the intermediate use cases. I also want to go over some advanced use cases that are related to Scrapy. We're also going to be going over unrelated Scrapy packages later on. So just a disclaimer here, you may not need these packages, but it's here if you actually need it, just in case. So these advanced packages are just really revolving around a specific use case, though these typically address the challenges around scaling, efficiency, and managing big code bases. So the first one I want to tackle is around scaling and efficiency in such a way that, suppose you're actually crawling a particular website, say an e-commerce website, and you're crawling it periodically, maybe every month, maybe every week, and your goal is to extract all of the items you could see inside the given web page, right, or website rather. In order to make your crawls more efficient, you want to avoid to crawl pages or items that you've seen before. And Scrapy Delta Fetch is able to give you this functionality. So if you need to retrieve only the unseen URLs or items from a given web page, it's able to determine this one because it's using BSD DB3 on the backend just to store the information about the previously seen items. So using this package could actually decrease the amount of time it takes to crawl really large websites and makes it more efficient. Next up is Scrapy JSON Schema. So this is just a way for actually validating items against a given schema. So any item that doesn't conform to the schema are dropped with a corresponding report. And the standard it uses here is JSON Schema. And declaring a given schema for a given item actually looks like this one. So suppose we're crawling ID, title, and price. You're able to declare the type for each field here. For ID, it's integer. For title, it's string. And for price, it's number. For numbers, you could also declare minimums there. And then for a given item, you could also declare the required fields that the item must possess to be deemed as valid. And if any of these rules are violated for a given item, it gets dropped, and then our corresponding report is in Scrapy would be sent out. So you'd actually know the problematic items out there. Okay, right. So this package named Scrapy Redis is, tackling use cases wherein we actually need to achieve scale, right? So the specific use case here is, suppose you want to need to distribute your crawls. Maybe you're crawling millions or even billions of web pages each month or each year, and in order to make your crawls more efficient, you would need some type of intermediate data layer that is shared across spiders. And by its name, Scrapy Redis uses Redis as the data layer by default. And the Redis storage here would accept either extracted items or even requests or responses. So you could actually do distributed processing or distributed crawls. So this is just one example out there of like how the configuration or model would look like, right? So suppose you have one or more spiders, you want to distribute the crawls in parallel, store some data, either items or requests or URLs inside the Redis queue, and other spiders would also run in parallel that are consuming their queue. So in this case, you would avoid running just a single spider by itself, and you're now able to run a lot of different spiders in parallel together, and makes your crawls much more faster. So another alternative here would be Frontera and Scrapy Frontera, but this mostly revolves around broad crawls. And broad crawls, by definition, is something that, if you're trying to crawl multiple domains, like maybe hundreds of thousands of domains that are unrelated to each other, you could use this one. So this is also another alternative, like away from Scrapy Redis, when you need to do distributed crawls. So this is just one example out here, wherein suppose we have just one producer spider, which just collects interesting URLs and stores it somewhere in a data layer. And now Frontera and Scrapy Frontera is now able to coordinate the crawls for different consumer spiders out there. It could be one or more. It really depends on your configuration. But so far, this is the most common model we use.
Kevin,
And then next,
you have one more
yeah.
minute until Q&A.
Right. Okay. Cool. Last one I want to discuss is Web Poet and Scrapy Poet. So this is just a way for you to actually, decouple your crawling and extraction logic away from each other. Because as you can see from the Scrapy example I've shown earlier, the crawling and extraction logic are inside the same code. So in this way, you could actually declare page objects, right? Wherein it only contains the extraction logic and not the crawling logic. So the crawling logic would mostly be residing inside a spider. All right, so I think I only have 1 minute, and just going over some advanced use case here without any relation to Scrapy. These are mostly revolving around machine learning for specific websites. The first one is page element detections for Masaurus. So if you actually want to detect forms available inside a given web page, say Facebook, it's able to do that one. As you can see here, it's able to determine that it's a login form with email and password fields. Next one is AutoPager, where you need a generic way without writing any parsers. It's able to detect the next pages on a given category. So in this case, it's book to scrape. It has the next button here, and it's able to crawl that accurately using machine learning. Next one is Soft 404s for those websites that doesn't return 404 status codes, but instead returns 200 status codes. So it's able to detect that one using probability. And then lastly, this is just not really related to machine learning, but helps in debugging. So if you actually need a way to compare two HTML pages together, you could use this one. Right, so I think that's it for my 1 minute. Yeah, I think we're Q&A time, Sigit.
Yes. Thanks a lot, Kevin, for the amazing presentation. We already have many questions from the participants. So the first one is from Emma. The question is, how do you handle non-standard CSS, especially when, for example, the developer of the website adding inline CSS in some of their page presentations as a shortcut solution for them, and when those websites are having redesign?
Right. Right. So I think it's a two-part question, right? So the first part here is actually inline CSS. So as I've mentioned before, you could also use Xpath because it's able to, have those functionalities wherein you could put a bit of some logic out there when declaring Xpath rules. So for CSS rules, if it's a bit wonky for non-standard CSS, we could actually resort to, trying to find texts inside a given page element. So I could, just search for a hot dog here, and I could use this a hot dog list here to actually determine that adjacent to it is definitely value that I want to get. And yeah, so websites having redesign is actually a big maintenance problem. So that's why I've pretty much introduced a lot of some introductions out there for web crawling and data extraction that revolves around machine learning, right? Because it's really hard to maintain parsers and by themselves. So if you could actually write some machine learning models out there to actually extract a lot of the rules for you, then you could avoid writing your parser when a site redesigns in some, maybe a few months or a few years. But it really depends on a given website.
Okay, the next question is from Fight Zeki. How do you overcome anti-bot mechanism from our website like Google Chapter, and how do you respond to robots.txt from our website?
Right. So the first one is we did not actually tackle the anti-bot mechanism for this talk, right? So we mostly revolved around crawling and extraction. But for anti-bot mechanisms, there's just a lot of services out there and that you could use. For example, in Scrapinghub, we have a service named Crawlera. So it takes all of the anti-bot mechanisms away from you. So you just send your spider request to Crawlera, and it's just able to rotate some proxies for you to take care of some issues like bannings or some rate limiting. And for robots.txt, Scrapy has a lot of middlewares. Scrapy actually has a middleware for actually handling robots.txt. So if you choose to, if you actually decide in using Scrapy, you could configure the default Scrapy middleware out there to configure the robots.txt. But by default, Scrapy out of the box obeys 100% of the robot.txt rules in a given website.
Okay, thank you. For the next question is from M. Adib Zamzam. What do you think about scraping their website? Is it possible?
Right. Yeah. So for Scrapinghub, we did have a blog post about it. So if you go to our, if you just search Scrapinghub and then blog and search for keywords like Memex, like the Memex program from DARPA from the US, that project actually revolves around crawling dark websites or the dark web basically. And if you'd actually search for GitHub for Team HG Memex or anything about Memex, it has a lot of Scrapy plugins, middlewares, and packages for you to actually crawl the dark web. So it's entirely possible to crawl it.
Yes. And then next question is from Yahya Fadullah Al-Fatih. What do you think about OS-in and how to develop OS-in?
Right. I'm actually not familiar, honestly, with OS-in. I'm actually Googling it now.
I think OS-in is open source intelligence.
Oh,
It is more
right.
about intelligence, like in NSA, NSA, National Security Agency, and I think it is web scraping is only a small part of it. So.
Right. So in my master's program, I actually written a paper about the Memex program because there's a lot of multiple, research revolving Memex. So Memex program is actually crawling the dark web pages in the web just to detect potential child trafficking or human trafficking, and US with its DARPA department out there is actually solving this problem. And they crawl a lot of web pages out there just to determine and create models and map out the dark web just to see where those child or human trafficking could be going for, or like revolving around with. So you could search for research papers about Memex. I think they actually cover a lot of parts for OSINT here.
Okay, thanks. For the next question is also from M. Adit Zamzam. What design pattern for Python that suits with distributed scraping?
Right. So a lot of so I only shared two architectures, or rather design patterns for distributed web scraping. Right. So the first one is like a hub and spoke model. So this is pretty much common. For example, I'm just going to go through some of my slides here. Right. So this one, we use this a lot. So like a producer and consumer spiders, mostly because websites out there has sitemaps inside their website. So if you could go to a particular website .com/sitemap or sitemap.xml, it's available there. It's basically mapping out the website for you for functionalities like SEO for Google. So they provide that one for you. So you could make a producer spider for it, which actually collects all of the URLs you could find inside a sitemap and put it somewhere, and have a lot of different spiders, consuming those sitemap URLs that it could find. And for another design pattern, just like this one, which is also pretty much common, wherein spiders are simply sharing information with each other. There's some alternatives out there like Kafka. Kafka is another common one, and you could construct a lot more complicated architecture or pipelines using Kafka, and it really depends on the use case you have in mind. But these two use cases out there, these are just basic building blocks, and you could combine them to however you want to fit inside your use case.
Okay, thank you. The next question is from Json Schema. How do you see the trend of data scraping, say in 5-10 years time, and how will it change?
Right. So I think the trend right now in tech is mostly revolving around increased use in machine learning algorithms or AI. Right. So I think it's also true for web crawling and data extraction. In fact, in Scrapinghub, we have a team of data scientists working around this problem. And we have a product named Auto Extract. So if you search for Scrapinghub Auto Extract, it's a product of ours that it's actually able to, extract the web pages for you, and in an automated way. So you don't even need to construct parsers around it. So it's able to, detect all the page elements out there without writing a single rule. And it actually works really well for really common websites, because a lot of the training models revolves around it. So I think in 5 to 10 years in time, there's less effort in actually writing parsers manually, and a lot more effort in writing machine learning models, so it could be automated.
Okay, thank you, Kevin. Actually, we have many other questions, but unfortunately, the time is up. So the last question is actually just, would you mind to share the presentation file?
I'm sorry?
The last question is just, will you share the presentation link?
Yep. I will be sharing the presentation.
Okay, you can share it on Discord, and we will share it to the audience. So thanks a lot, Kevin, for your amazing presentation. And thank you for the participant for watching us. So See you at the next session. Bye.
Yep. Thanks, guys.